In last two parts of this series, I explained how to create a network component in AWS. It was consist of a VPC, internet gateway, subnets, routing table, NAT gateway, and so on. In this video, I will speak about variables. They will play a key role in Terragrunt configuration, and also will explain about Tfstate files and remote backend, because they are very important for using in a team working and also for multi-environment configuration. And finally, we will change this network component to a module, and we will see how it can help us in Terragrunt configuration. Let's start. Based on our Terraform code, we have created a tutorial VPC on US East 1. Now, if I want to create another new VPC, we can use the same code that we used in last videos. But the CIDR should be different. Why? 1. It is a new network. 2. The VPCs should not have overlaps. This is the first network. This is the second network. The CIDR block here 10.100.0.0/16. CIDR block in second network should be different, because if the CIDR block on both of them be the same, they cannot communicate with each other. So one way is going to our Terraform code and find the VPC CIDR block and change it. But if we want to control them centrally and in a separate file, just change this code and don't touch the main file, we need variable. How to define a variable? This is the format for the variable. Just type this keyword variable, give it a name, and we can add some item, for example, description. This variable is for what? Also, we can define a default. If we don't define the default in variable, when we run the Terraform code, it will ask for the content. Let's create the first variable, and after that we can play with it and see what will happen with variable. For example, for this VPC block, I want to define a variable for CIDR block. Just here, define, for example, variable VPC underline CIDR, and in description VPC CIDR block, and as a default this one. So for using this variable in resource, just remove this one and type this keyword var dot the name of the variable. Done. When we run the Terraform code, when arrive to this line, we'll go to variable block and take this default. If they cannot find this default, it will ask for the content. Let's back to our code. So as I told you, let's create a variable here. Just type VPC CIDR and a description, VPC CIDR block default. So let's remove this one. As I told you, just type var dot and the name of the variable. It's done. In best practice, it is better to create a file. It's called, for example, variables.tf, and transfer this variable block to variables. And the same for the subnet. we can create here a variable public subnet CIDR. Description, default, take it from here in the variable. Let's copy this one. And for the private subnet CIDR and 3. Let's back here and remove this one. Var dot automatically show us. We select the public one, and for the private one also remove this one. Var dot select the private one. Control S, save it, and let's run Terraform plan. You see, when we run Terraform plan or apply, it will go and automatically run all the TF file that we have here. And when arrive to variables, for example, like this one, it will go and search in the TF file for that. If couldn't file, will show you what is the value for this variable. If find, automatically take the value from the variable files and run your code. Let's clean the screen and going to the variable file and comment, for example, this one. So here we didn't declare or define any default for the private subnet CIDR. So here, when I run Terraform plan, ask me what is the value for the private subnet CIDR. As soon as I enter the value for that, it will go and run the code. There is another way that we want to pass the value from the command line. At first, let's go into the Google. In Google, just search for Terraform variable, and from the first one that belong to Terraform official document, it show us input variables. Let's going down here, how to declare an input variable. As I told you, variable, name, and description or default. And let's going down here, you see all the argument that you can use in the variable, default, description, and other ones. You see here using input variables value. As I told you, for using the variable, just type var dot and the name of the variable that you define in variables file. You see here variables on the command line. If you want to pass the value from the command line, you should use like that, -var equal the variable you want to define. Let's back to code. Here, just Terraform plan -var equal, what's the name of the variable? Private CIDR 10 130/24. Let's run it. See, in this time, we didn't get any issue or any message that asked for the value. We didn't get any issue or any message for enter the value. So here we have learned in the variable file, we can declare the value for the variable by using the default. If we don't define by default, we can give it handy like here, or we can pass it by -var to the command line and run the Terraform code. Let's comment all the default here and run the Terraform plan. You see, ask at first for the private one. If we enter that, again we'll ask the public one, and after that ask the VPC CIDR block. Sorry, it should be 0, and after that we'll run the code. Here there is another way to declare the variables. As I told you before, maybe we want to use this Terraform code for another environment. For example, we have a development environment, we have a production, we have a test, and so on. So every time we want to run this Terraform code for each environment, we should change the VPC CIDR block and subnet CIDRs. So if we don't want to touch the main file and variables file, and also we don't want enter by handy in the command line, there is another way and make our job very dynamically. Let's back to Terraform documentation. Here you see a title variable definition.tfvars file. We can create a file with this extension Tfvars and declare our variables inside that. We can give it every name we want, but when we want to run the Terraform code, we should define the name of that Tfvars here. For prevent to define every time like this one, we can select Terraform name. Let's show you. Create a file called terraform.tfvars. When we define with this name, automatically when we run, the Terraform code will find this file and run it. But if we don't use the Terraform name in the command line, we should use like this as in documentation. If the name of the file, for example, was testing, we should like that. But here, as I told you, it is better to using the Terraform name. So in the terraform.tfvars, we should copy the name of the variables on that public subnet, Control C, copy here, and the private one. Here equal to 10.100.0.0/16, and for the anothers, let's run Terraform plan. Oops, why show us this one? Okay, let's see. Okay, you see here, I lost an R. Let's correct it and cancel and rerun that. You see, it's done. So instead of declare the variables in command line, we have created a Tfvars file and declared all the variables here. As I told you, if I change the name of that to any other name like test, when I want to run that, you should define like this. Otherwise, it doesn't work. Let me show you. Here, you see, request to enter the value for the CIDRs. So let's back here and change it to Terraform. Let's run and see everything is okay. This declaration is very useful in architecture and designing by Terraform. We will see in Terragrunt, this Tfvars will help us to design a multi-environment very useful. Okay, let's continue to another subject. I wanted to delete all the file. Only I wanted to keep my Terraform codes. For the first time when I run Terraform init, it will go and download AWS plugin that make us to communicate with AWS cloud system. All the plugins save it here. When we run Terraform apply, see here, it will create a Terraform.Tfstate. Say yes. You see, it will go and create our network component on AWS. Okay, it's done. Let's going a little dive in Terraform Tfstate file. Here I want to talk a little about Tfstate file and backend. Terraform must store a state about your managed infrastructure and configuration. So every time we run Terraform, it records information about what infrastructure it created in a Terraform state file. So we can say this state file is a map between real-world resources to your Terraform configuration. It's one by one map. We can say in simple language, it is like a key value database. Everything related to our infrastructure record in Tfstate file. The format of the Tfstate files are JSON. You see here, JSON is like a key value language. Key, for example, here is version and the value is 4. Which Terraform version we are using? This is a key and this content is the value. You see here the list of the availability zone for the US East one. For example, you see here NAT gateway. If you remember, we told NAT gateway has two legs, one in the private and one in the public section. You see here the private IP that belongs to the private leg of the NAT gateway, and it is from the private subnet range. Also, we allocated that a public IP. So what happened if we delete the Terraform Tfstate file? It is like we delete all the information in a database, and Terraform cannot manage infrastructure. What is the backend? A backend defines where Terraform stores its state data file, where this Tfstate file should be stored. By default, as you see here, it stores in our local computer. But if we give this Terraform code to another guy in our team, and if run the Terraform, it will go to rebuild this infrastructure again because there is no Tfstate file on his computer. Otherwise, we can send also the Terraform Tfstate file to him or her, and then he can manage the infrastructure. But it is not a good way. Is there any other way that we can manage the Tfstate file? Yes, there is a remote backend. Local backend, it means in our computer. Remote backend, it means in another place that we can put this Terraform Tfstate file, and every time a team worker wanna use the Terraform code, automatically access to this remote state file and use them. At the moment, with the latest version of Terraform, there are some remote backend. Azure RM. It is a specific backend for Azure, Console, COS, GCP. It is Google Cloud, HTTP. We can use HTTP backend with the GitLab. I had a video about it before, so I will pin it above of this video and you can refer that and see how we can use HTTP backend as a remote. Also, we can use Kubernetes, OSS, PG, and one of the famous of them is S3. S3 is belong to AWS. Normally for AWS remote backend, we're gonna use S3. Every time we change in backend configuration, we should use Terraform init to initialize again our configuration. How we can use it in the Terraform block, just using the backend and give the name which backend we are using and configuration. Let's back to our configuration. This is the Terraform block that I told you. Okay, click here and paste the code here. Backend S3 bucket, the name of the bucket. We have to create a bucket and put the name here. Also a key. I will describe what is the key here and which region we wanted to create that in US East one. You can create in every region you want. Let's back to documentation. In documentation, if you see here, S3 stores the state as a given key in a given bucket on Amazon S3. Also, you see here, this backend also supports state locking. So what is state locking? If two workmates work in the same time on Terraform, by DynamoDB, we can lock it. For example, if the first one is working, automatically the provisioning will be locked and another team workmate cannot deploying in the same time for prevent any issue. So we can add DynamoDB table argument to our configuration. Here you see DynamoDB state locking, DynamoDB table. It is optional, but it is recommended to use it. So let's copy DynamoDB table to our configuration file. Copy DynamoDB and back to configuration and add it here. Also, we have to create a DynamoDB table on AWS based on this instruction here. See, the table must have a partition key named lock ID with type of string. Let's connect to AWS console. Here we type for S3. In S3, just create a bucket, give it a name. The name should be unique. Let me select this one, Terraform Tfstate bucket in US is one, and let's back to documentation. You see here in document mention, it is highly recommended that you enable bucket versioning on the S3 bucket. So in configuration, we enable bucket versioning, and that's done. It seems the name that I have selected before another guy use it. So let me add a number to it. It seems this one is okay. Create bucket. So the bucket created. We have to copy the name of the bucket to the Terraform configuration. Also for the key, if I click on the bucket name, here you see we have nothing here. Also here we can create a folder, for example, tutorial, and in Terraform configuration in the key, just for the path, we can use tutorial and give a name for our state file. For example, network.tfstate. For the DynamoDB, let's back to AWS console and type DynamoDB and click on tables. Let's create a table. Select a name like S3, put it here. And for the partition key, let's back to documentation. In documentation, you see we have to create a partition key named lock ID. Control C, back to console, partition key, lock ID, and type should be a string based on the documentation. Let's create that. It's creating. Let's back to Terraform and copy the name here. Control S. Let's check the console. If everything is ready, we can continue and run our Terraform code. Yes, it is active. So let's run our Terraform. I told you as soon as we do a change in backend, we have run Terraform init. You see, initializing the backend. Want to copy existing state to the new backend? Yes, and automatically copy this state file from our local computer to the new one, because at the moment our network component is deployed and we need this state file. Yes, successfully configured the backend S3. Terraform will automatically use this backend unless the backend changes. Let's back to console. Let's going to S31. This is our bucket tutorial. This is our network Tfstate file. Our state file is recorded here. Until now, we have learned about the variables and Tfstate file and remote backend. Really, I don't want this video take more time, so I will continue in next part.